Hi, today we are going to talk about Ethereum and creating smart contracts using Ethereum and blockchain. I'm Rishabh, a third year computer science student, and this is my co-presenter who is also a third year computer science major. In this video, we'll learn about blockchains and decentralized applications or DApps. Then we'll move on to learning more about Ethereum and creating smart contracts. And in the end, we'll build one basic smart contract.
A blockchain is essentially a decentralized database or an open distributed ledger that keeps records of who owns what. Here we have a centralized system which is highly dependent on the central node. Compared to this, you can see the advantages of the decentralized and distributed systems where such a high level of dependence is not required, which means that even if one node is compromised, the rest will carry on without any issues. One way of representing the open ledger is using the concept of Google spreadsheets. We can all see an open spreadsheet and all the records of the changes or the transactions. The difference here is that in a blockchain, no one can modify it. You can only add to it, which reduces illegal changes by keeping a record of all the transactions. So here's how it all works. A block of transactions is validated and time-stamped and then added to a chain of blocks. As these new blocks are linked to older blocks instead of modifying them, every single transaction remains visible in the history of the blockchain. The entire chain is continually updated, so every ledger in the network is the same and has the ability to prove who owns what at any given time. This is quite different from how traditional banks work. They are a centralized system who control all records. Let's take a deeper look. It starts with someone requesting a transaction, which is then broadcast to the entire network. The transaction is validated and verified by a network of nodes. Once the transaction is verified, it is combined with other similar transactions to create a new block of data for the open ledger. The new block is then added to the blockchain in an unalterable and permanent way. This completes the transaction. Decentralized applications are completely open source applications which operate in an autonomous manner and are not controlled by a majority holding entity. They must meet these four criteria. Decentralized applications must be open source, autonomous, and not controlled by a single entity. Data must be cryptographically stored in a distributed blockchain, and all changes to the application must be by consensus. A cryptographic token should be used for access, as well as to provide a reward to the network or supporters or miners. These tokens must be generated by an algorithm capable of valuing contributions to the system. Now, keeping in mind what decentralized applications are, let us introduce Ethereum. It is a decentralized computing platform that anyone can use to create applications. In order to pay for the computing power used to execute these programs, a cryptocurrency called Ether is used. Therefore, Ethereum allows us to create decentralized applications powered by the Ethereum blockchain.
Now let's explore some topics related to Ethereum. Ether is the official currency of the Ethereum blockchain. You can pay or buy Ether in exchange for computing services offered. A Wei is a denomination of Ether. 1 Ether amounts to 10 to the power 18 Wei. A gas is a special unit which basically is used to calculate the amount of work done or the amount of computation done. Then we move on to smart contracts. Smart contracts is a code on the Ethereum blockchain which will execute and implement the terms of an agreement between parties. So it's like a lawyer on the Ethereum blockchain. Now let's get into Solidity. Solidity is a contract-based programming language maintained by the Ethereum organization. It's very similar to JavaScript. It's used to create contracts on the Ethereum blockchain. Here we have the official Solidity IDE. We write code here to create a contract, visualize, and debug. The console here explains what information will go to the user. We can enter the value here. This button creates the contract. As we can see, the contract was created. These are the functions that are associated with a sell shares contract. This contract implements a company's contract sharing system. So I can create a value that will be sent to the contract on the blockchain and click on the function to buy shares. So I'll be buying 100 into 10 shares of the company. So when I click on buy shares, the code is executed and we get no errors. If you want to check how much money we have, how many shares we have, we can click on balance of, which gives us the shares. It's 1000. So we had 100 way, and each way gives 10 shares. So we got 1000 shares, as we can see here. And so these are two functions, buy shares and balance of, which gives us the balance once you provide the address. The function supply gives us how many shares have already been bought, and so on and so forth. These are basically functions that implement the share. And if we want to look at what information is logged into the blockchain, we can click on details here, and this information right here has all the details, and this is what is stored in the block. This information right here, the transaction cost, input, and this can never ever be edited. So let's go through the code and see what each line does. So the first line of code basically assigns what compiler version we want to use to execute this contract. Then we declare the contract, sell shares. It's exactly like declaring a class. A contract has data members and data member functions that we will talk about in a moment. Here we initialize the code with the maximum shares, the value of each share, and the supply. The supply will basically hold the number of purchased shares. This is a map function where we map the address of the user to the balance. So we are associating the user with the balance. Here we have a modifier which executes. This requires a assert statement. If this statement is true, the function calling the modifier is run. This is a function check balance which returns the balance of the user, and this is again the same function, but this returns the total value of the shareholder. Again, this is the actual function that we first implemented, buy shares. This takes in the share amount, calculates the share value. So we had one way is equal to 10 shares. So when we had 100 shares, we had a value of 100. We multiplied it by 10. So we had 1000 way. Then the dictionary, where the key was the address of the sender, is updated with the shares the sender has, and the supply is also updated. And the reason supply is updated is because we need to check that we have enough supply of shares to actually sell shares.
Let's move on to the applications of smart contracts. The first major application is definitely the Internet of Things. We can use smart contracts to validate each step of the supply chain process. This includes automating package delivery, with blockchain adding checks at every step to ensure that no packages are lost. It would make drone delivery so much more reliable and has huge retail applications as well. Another big area is managing a smart city. Smart contracts would enable auto-charging electric cars based on when the price is right, and automatic selling of home-generated solar power when there is excess, all based on predetermined variable contracts. This could even permit us to autonomously service water heaters and furnaces when required. The next major application of smart contracts is cybersecurity. We could have used a smart contract to simplify voting on these very videos, while at the same time ensuring a tamper-proof system as well as proper verification of users. The consensus protocols that smart contracts are based on, proof of work and proof of stake, enable us to eliminate identity theft by providing a public key infrastructure with no point of failure. A blockchain would also prevent data tampering because you can only add a block to a blockchain, not modify it. The last cybersecurity application of smart contracts is its ability to stop distributed denial of service attacks. A decentralized system does not have a single vulnerable target.
Well, that was a lot to take in for 10 minutes, I agree. We learned about blockchain and decentralized apps. Then we delved deeper into Ethereum and what are smart contracts, and we implemented a very basic contract. More resources that would really help you augment your understanding would be the white papers on smart contracts on Ethereum by the actual organizations behind them, and the last is a link to the code shown in the video before. Thank you.